We ready?
Good.
Good. Roll cameras. Hi, I'm Andrew Lindsay. I don't know if many of you don't know me or what I've been doing lately, but I've been involved with a lot of the Ethernet libraries that are used on the Nanodes and Arduinos and the Ether Shields. Something I've been working on recently is uploading sketches and getting them to be programmed using a modified bootloader. What I'm presenting to you today is a solution. It's not a final solution, it's not a perfect solution, but it is something that is working at present. So what do we want to do a remote sketch upload for? Well, if you've got one of these devices that's stuck in your hallway somewhere, in another room, wherever, you don't want to be taking it down, uploading your updates, putting it back up. Well, basically, don't want to return them to base if they're out in your shed. And I think it's something cool. Why not? If we can do it, that's one up to us rather than the other fellas. I see a couple of solutions that I basically call them code push and code pull. Code push, we're actually, as a user, you are sending the code out to a Nanode, so you need to know its address. You have no central sort of code server, you just got to compile up your sketch, send it out to it, and it sits there listening and reprograms itself. The other way is code pull, where the Nanode on a regular basis checks in with the remote server and says, have you got a new version of software for me? And if it says yes, it downloads it, saves it into the local SRAM, and then reprograms itself. This would need a central server and probably management software of it, on it, that sort of thing. My solution is more of a proof of concept, that it can be done. Basically what I'm doing is using a TFTP client on my laptop here, and I've got a TFTP server written, and it's running on the Nanode there. I've got some extra LEDs on there just to show that I know that it's going into the bootloader. Basically what I do is I take the hex file that's been compiled by the Arduino IDE, save it somewhere else so I know where it is, because it sticks into these temporary directories that nobody can ever find a second time. Basically just use a simple client and send it on. I'm going to do a little demonstration. Basically all we're going to do is load the sketch and see that it runs. You bear with me for 30 seconds. I've got, where is it?
So what measures are there to, if any, to prevent sort of malicious reprogramming?
No.
Alright.
We'll answer that in a minute. Basically what you can do is if you hold down the shift key, you get a load of extra debugs down in the bottom here. And one of the things is it tells you where your sketch is with the .hex on the end. So that's your the code that you want to program. So what I do, I'll just hold that over. Where's the camera? There we are. That's the main LED. It'll flash eventually. These two will flash when it's doing the bootloader part. So all I need to do is I'm using this thing called TFTPD64. I've set up the IP address of the Nanode. I've set up the port 69 for the TFTP. Give it the hex file, and then all I need to do is just say put, and it's done. And it's sent it, and it's starting to flash the LEDs there, and it's now running the new sketch, which was just a simple blink sketch to flash these LEDs. Did anyone miss that? It was problem with this is now I've replaced the sketch with something that doesn't have any of the network code in. I'm going to go and put it back, get the right one. Is that doing it? Yeah. And one of the modifications on this bootloader is it actually flashes the LED when it's transferring the data. So you can see it's done something right. And that's now running. Sketch, you can reset it, you can see the LEDs flashing as it does and the library starts up. One of the things you can do is get it to reprogram itself. So that's now sent the same sketch back to it. It's telling me that the bootloader's running and it's now programming it. The LEDs are flashing and it's restarted. So I should, in theory, then be able to transfer the sketch again and keep doing that. I've basically saved it into the little SRAM chip that's on the back of the board. So you've seen that we transfer the sketches to there and they can update. But it's still a work in progress. The bootloader is quite large because I had to go to the next level of size just to fit in an extra few bytes. It needs some optimization. I've tried looking at the OptiBoot bootloader, but I couldn't actually get that to work reliably in this code. In this case, sorry. Where did I put SRAM code? Isn't very big. Oh yeah. Should really read my notes properly before I start this. Yeah, the number of bytes in the code for the SRAM handling isn't very large. There's only a few minor functions. We're not writing to the SRAM, we're just reading for it. So all we're doing is setting the address, reading values out, putting them straight into a buffer, putting it straight into the flash. Still needs more work on the delivery method. How do we deliver the stuff? Push, pull. But the basic concepts of putting something into the SRAM, getting the bootloader to recognise that it's there and reprogram itself as they're working. So the other things to consider, do we go for a binary format to send it in, or as in the example here, and then use the standard Intel hex that the files are compiled and linked to. Basically saves an extra step of somebody having to convert it, then send it off. And one thing that's already been mentioned is security and verification. The TFTP protocol doesn't have any of that at the minute, so it could really be open to abuse. There are ways that it could be fixed by wrapping the application, wrapping the hex file in some other wrapper, signed wrapper, or whatever that could identify it as a valid.
A bit like PGP, but probably a lot lighter. So
something like that, yes.
Andy, how much of the program space is required for the network routines? So let's say we had an extra SPI ROM on board that basically has Arduino Nanode 1.0 in it, right? And they're shipped from the manufacturer with this get out of jail free card already programmed into them. So if you go through this process and you brick the board, you can then do a cold restart and then you can download the code that you should really have there in the first place. So just by adding an SPI ROM on there, it's got all your network stuff on. So if you do break the board, you can
see how big this is yet. I've not done any calculations to see how much space the TFTP code takes.
Yeah.
At the minute, it's just a sketch there. I've not integrated it in with the library or anything like that, or even tried putting it into the bootloader, which is an option other people are investigating.
Sure.
But something I don't think is probably practical at the minute.
Was your TXT server that was running on the Nanode running from the originally from the SRAM, and then you say you put it into Flash?
No, it runs as a sketch.
Okay.
It's just a regular sketch that's uploaded. All it's doing is just listening for a TFTP put request.
At one point, I noticed that you had to flash again using the FTDI cable rather than the network connection. So what
That was because I uploaded a simple Blink sketch, and because that doesn't have any network code in it, it was not able to then receive another update.
So you receive the hex file over the LAN connection, then it locally flashes its own firmware over what was on the actual...
Well, that was to put it back to reset the test, reset the demonstration.
Could you make it so that it doesn't overwrite that networking code and commit suicide when you reprogram it, and just replace the...
Well, this is the thing, these Nanodes are sort of network appliance. So I would see that all the code that you would upload into it would have the network library in there. The Blink that I just loaded was just a simple demo, just to show you're actually doing something. Trying to demonstrate network stuff on here is, well, you can't see that it's doing much, can you?
It's just that if the code that you uploaded to it had an error in it, you may find that you lose your network connectivity.
That is a possibility, but then you'd have to...
This is why the belt and braces of having
testing
a local image of that stored in non-volatile.
How do you communicate with it to get it to initialize that ROM reading and then transfer back on? You lost connectivity with it. You still have to
You'd have a watchdog, so that if it timed out, if it didn't execute a bit of code within a certain amount of time, it knows it's killed itself. So that invokes a routine or a jump to some code that reprograms locally, and then it reappears on the network. And probably the first thing you should do is then call into some server saying, "Help!"
Any more questions?
The pool mechanism has a disadvantage if the Nanode is behind the router, as opposite of a push solution. Oh, sorry, the other way around. The push solution has a disadvantage if a Nanode is behind the
It's more like they're on your local LAN and you can see them all and you just push them out individually.
Yeah, okay.
It'd be a nice proof of concept though to open up the ports over your router and then program a Nanode on the other side of the world over the internet.
That's tomorrow afternoon. Last thing.
It's completely
Cool. Okay. Thank you. Thank you.
Well done.
Did you try the very latest after you looked? Because a fair amount of work's been done on this.